In number 53, we have three displacements, d1, d2, and d3. And the first question is, what's r, which is d1 minus d2 plus d3. So down here in A, we've got r, and I'm going to go ahead and break it in. Remember, when you're adding or subtracting vectors, you just have to add the components. So I've put all the components of d1 is blue, all the components of d2 is red, all the components of d3 is green, and all we need to do is add together those components for I hat, j hat, and k hat. If we do that, we'll discover the answer in this one, simply 9I hat plus 6j hat minus 7k hat. B, what's the angle between this new vector and the positive z-axis? Well, the positive z-axis is along k hat. And so I'm just simply going to use k hat for that vector. And if you remember, to figure out an easy way to figure out the angle between two vectors, you can either use dot product or cross product. Dot product is just so much easier to calculate. I'm just going to use the dot product in this case. So going ahead and do the dot product. Writing in r, which is the one we just solved, 9I hat plus 6j hat minus 7k hat. And for the k direction, I'm just going to use 1k. And that's going to equal the magnitude of r, which is going to be the square of each of those terms, the square root of that, plus the magnitude of my 1k, which is just going to be 1 over here. That's just plain nice. Doing the number crunching on this one, we'll get negative 7. That's the dot product. It's just going to be the negative 7 here times 1, since these are the two k hat terms. And then the square root of this whole spiel is going to give us 12.8. And of course, this is 1. And then times cosine of theta. And very quickly, you can do cosine of theta. It's going to be about 123 degrees. C, what's the component of d1 along the direction of d2? And you might say, whoa, what in the world is going on here? Whoops, going the wrong way. If you remember, the dot product literally finds the component of b that is along a. And so that's what we say, a dot b is actually equal to a times b cosine theta. Well, b cosine theta is literally the component of this vector b along vector a. So we're going to do the exact same thing except with d1 and d2. So there's our dot product. We know it's equal to that. But we're interested just in d1 cosine theta. We want to know that fraction that's along there. So this is actually that component that we're trying to solve for. So how do we do that? Well, we just need to do the dot product and divide it by the magnitude of d2. Doing that down below here, we get this. And you're like, whoa, magnitude of d2? Yeah, again, remember d2 is negative 1, 2, and 3 up here. And so those magnitudes go down here. The dot product is going to be fairly friendly. Remember, we're just going to do 4 times negative 1 plus 5 times 2 plus negative 6 times 3. If we do that, we get negative 12, and the square root of 14, the one below there, gives us that. Dividing that out gives us our magnitude, negative 3.21 meters. And you might say, whoa, wait a second, how can it be negative? The answer is our second vector in this case is probably pointing this way. And so the component along that is going to be in the negative direction if A was the other vector. Finally, we get to D. What's the component of D1 that is perpendicular to the direction of D2 and in the plane of those two? And you might say, whoa, what in the world's going on here? Basically, what they're trying to do here is the cross product. And a quick note about this, if you haven't thought about it already, remember the cross product, its magnitude is equal to the area of this parallelogram. And if you're not familiar with it, the area of a parallelogram can also be written as simply the height of the parallelogram times its width. Well, technically, what we're looking for right here is h. How can we find h? We're going to take the area of the parallelogram, which is the cross product, or the magnitude of the cross product, and divide it by a. So again, the cross product is going to give us that. And in this case, rearranging it, we want to know basically this piece right here. This is basically our height. along in that plane. We're taking the total area divided by d2, which is sort of like a in this case down here. Plugging in the numbers, in this case we got to do a cross product. Cross product's a little bit more challenging. You can use either the matrices method, you could write it out the long way, or if you've got a TI Inspire, you can use the cross product function. I was lazy, used the cross product function, gave me the coefficients of 27i hat, negative 6j hat, 13k hat, and we're only interested in its magnitude. This top part here is going to be the area of the parallelogram and divided by the length of D2. If you do that, you get 8.17 meters. Hopefully that helps. This one is one of the more mathematical problems in your homework. Good luck. Talk to you soon.